Okay, so we're talking about rectangles with an area of 205 square feet. And let x be the length of one side. So if your area of a rectangle, it's length times width, right? So we can call x the length or x the width. It doesn't really matter. So I'll call x my length times some L that I don't know for, oh, sorry, it's times some W for my width. So we have a number we can put in here. 205 is the area we're told. So we still have two variables, two things we don't know. But I can put W in terms of x, right? I could just divide that x from both sides and then I'd have W in terms of x. But here's the reason why we're doing that, because in part A, they say express the perimeter as a function of x. The perimeter of a rectangle is two lengths plus two widths, right? The lengths of the entire outside of the rectangle. But we're supposed to have it as a function of x. So x is supposed to be the only variable going on. So I said, hey, let's let x be our length. So that's fine. We just have x going on. Oh, sorry. We just have x going on so far. But I can't put 2w or else it's not a function of x. That's why I can use this equation up here. I can rearrange. I can get w by itself. I can divide that x from both sides. And now I have something for w in terms of x. It's 205 divided by x. So now I can finish out my function. It's 2 times 205 over x. Okay, so anytime they ask you to make a function of x, then x should be your only variable inside that function. I couldn't put w in here. I had to rearrange w using that first fact that that the area equals length times width. And so now it's a function of x. So you could say p of x equals all this stuff. So that's our perimeter as a function of x. Find the dimensions of the rectangle that has the least perimeter. I don't know. Here, I can multiply that 2 to the 205. That's 410. I mean, I know a calculus way of doing it. We gotta make the perimeter as small as possible. No, I gotta think about this for a second. So, with calculus, we have a technique for finding minimums and maximums. You can take a derivative, set it equal to 0, but at this point in your course, you don't know what a derivative is. So let's graph it. I think that's the only way you can do it. Okay, so I've typed in the right side. You could say y equals, whoa, what happened? There we go. Okay, so I typed in the right side of the equation of the function into Desmos. I gotta zoom out with this. Okay, and then we can find the minimum by tracing the graph down here. So x equals 14.32 causes us to reach a minimum, because this is, remember, this is an expression for the perimeter. The y values out of the graph are the perimeter, right? Because this was like where our y usually goes in our y and x equations. So when x is 14.32, y is 57.27. So that's the minimum for mine, 57.27. So when you do your problem, graph it in desmos.com/calculator and then find your minimum just like I did. We don't care about this one, right? Because that's negative perimeter.